In this video, I want to provide a proof of the propensity score theorem, which I referenced in the last video. So just to reiterate what the propensity score theorem is, it says, well, if the conditional independence assumption holds, and the conditional independence assumption says that the potential values of an outcome variable, so that's, let's say in the case of having a particularly binary treatment, might be y0i and y1i, it says that these potential outcomes are independent of the treatment given a vector of covariates x. Well, the propensity score theorem says, well, if the conditional independence assumption holds, then it happens to be the case that those two outcome variables, y0i and y1i, are themselves independent of di, conditional on the propensity score, so the probability which an individual will receive treatment given their list of covariates xi. And I spoke about how this is a really useful theorem because the problem with stratifying across xi is that this is highly dimensional. And what that means in practice is that there may not always be corresponding individuals which we can make up subsamples for in our untreated set to match that of the treated set. Whereas this quantity here is just a scalar quantity. So because it's a scalar quantity, that means that it's one-dimensional, so stratifying across that probability is going to be a lot easier, and the sort of space is going to be a lot richer than that of the highly dimensional xi space, which is likely going to be relatively sparse. Okay, so how do we go ahead and prove this? I'm actually going to follow a proof which is exactly the same as that which is found in the book Mostly Harmless Econometrics, which is an absolutely excellent book. It's a book by Angrish and Fisk, and it's a very good graduate level study book, and I very much recommend you have a look at it. But anyway, just to reference that I'm actually going to use exactly the same proof which they quote in Mostly Harmless Econometrics. Okay, so how do we go ahead and prove this? Well, the idea is that if we consider the probability which an individual receives treatment, given now their potential level of outcome, so that's yji, where I'm saying j can take on the values 1 or 0 here, and also given their propensity score, so if we consider this quantity, if we can show that this quantity is not a function of yji, then in doing so we will have proved that there is an independence rather between y0i, y1i and di conditional on p of xi. Okay, so first of all we recognise that this quantity here is exactly the same thing as the expectation of di given yji and also given the propensity score for an individual I. This is just importantly, this is an I here, not a j. And the reason that these two things are exactly the same is that the expectation of this is equivalent to 1 times the probability that di equals 1 given yji and also given the propensity score, and plus 0 times the probability which di is equal to 0, etc., etc. And because of the fact that this second term is 0, that is what equates this term up here with this term directly below it. We're going to continue our proof of the propensity score theorem in the next video, and we're going to prove that the treatment is independent of the potential outcome variables, conditional on the propensity score.